Hello, good morning, everyone, dear authors and invited guests. Welcome to Technical Session 7C. Myself, Karthik Bharadwaj, and this session would be moderated by me. On behalf of Global Knowledge Trust Foundation and GR Solistic LLP, it's my great pleasure to welcome you to this 10th International Conference. Just a second. To this 10th International Conference uh, on Smart Trends in Computing and Communication, SMARTCOM 2026, Pune, India. The 10th edition of this conference is being organized in a hybrid mode. The physical event is held today in Pune, India, and the virtual event is being organized through Zoom from 19th to 21st of January 2026. I hope you will enjoy the knowledgeable interactive session throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for their presentation and 2 minutes for question answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you stay connected to the closing remark. If you have any query or any update, you can write it to me in the chat box. Just before we get started, I'd like to introduce you with today's session chair, Dr. Tatvadarshi. Dr. Tatvadarshi is an associate professor and head of department of artificial intelligence and data science at College of Engineering and Technology, Maharashtra, India. I request our respected session chair to kindly address our participants.
Yeah, good morning, everyone, and thank you, Karthik, for the introduction and welcome. Uh, so, I'm excited to hear from the latest research that is going on. So, yeah, we can begin with the session.
Thank you, sir. I give you a brief introduction about Dr. Tatvadarshi also. Dr. Tatvadarshi is an associate professor and head of Department of Artificial Intelligence and Data Science in the College of Engineering and Technology, Maharashtra, with extensive experience in academia. His expertise spans in machine learning, deep learning, and natural language processing. He has authored over 50 research papers at both national and international conference. Dr. Tatvadarshi is keen on collaborative research in areas including data science, NLP, deep learning, AI, and data security. Sir, thank you for joining us today.
Thank you for
Now,
having me here. Yeah.
thank you, sir. Now we'll be starting the first presentation of the day. For the first presentation, I like to call Bethy for the paper title, A Hybrid Machine Learning and Deep Learning Approach for Classifying 7 Major Cancers Using Symptom and Gene Expression Profiles. I request the presenter to kindly proceed with their presentation.
Um, okay, can you confirm me if you can see my screen or if you can listen my voice?
Ma'am, your screen is visible to us and you're audible too. You can proceed. Thank you.
Good morning, everyone. My name is Bithi Khanum, and today I'll be presenting our work, a hybrid machine learning and deep learning approach for classifying 7 major cancers using symptom and gene expression profiles at SmartCom 2026. Our paper ID is 391, and this is a collaborative work with my co-authors from RP Shah University. First, I'll briefly cover our motivation methodology, our proposed DMLP-NATE model, key results, and finally, I will also talk about our future plan with this work. The motivation is quite simple. Early diagnosis saves life, but it's difficult because many cancers share similar symptoms, and symptoms alone may not be enough for confident classification. At the same time, gene expression provides strong molecular signals, but it is also high dimensional and hard to handle. So our goal is to build a model that is both highly accurate and computationally efficient with potential use in low resource clinical settings. So in this work, what we did is we proposed a two-stage approach. First, we analyze cancer classification using symptom level clinical data. And secondly, we analyze classification using gene expression data. We evaluate baseline machine learning models and then introduce a deep learning model called DMLP-NATE. Full form is Deep Multilayer Perceptor Network. It is supported by random forest feature selection, and our results are quite strong. The model achieves 98.08% accuracy using symptom data and 99.29% accuracy using gene expression data. Now I will briefly explain why this topic really matters. As all of you know, cancer is one of the most serious global health challenges. In many cases, patients do not show unique early symptoms, and different cancers can look similar in early stages. Because of this, diagnosis often depends on inexpensive or invasive tests like imaging or biopsy. So these methods are also not always accessible, and delays can reduce survival chances too. So we need a reliable method that can support early screening and decision making using data that can be available earlier, like symptoms, and data that are highly informative, like gene expression. So in the symptom-based classification, we started the process with clinical symptom information. We build our data set and then we perform our feature selection. After that, we train multiple baseline machine learning models and then to our deep learning approach called GMLP. And finally, we evaluate the performances. Similarly, for gene expression based classification, we use gene expression profile because gene dataset contains thousands of feature. We applied pre-processing and normalization, then feature selection to reduce the dimensionality. After that, we train our baseline machine learning models and deep learning approach. Finally, we evaluate our performance carefully. Now moving to the methodology of this work, the symptom-based dataset. For symptom-based dataset, we used data collected from 505 patients containing 47 symptom-related features, which is collected from NICRH, which is Cancer Research Hospital in Bangladesh. For pre-processing, symptom features are encoded in binary format. We also use stratified simple sampling applied for the balancing the cancer, and we also used Z-score normalization for gene expression data and coded class levels numerically, and then split the data set into training, validation, and test sets. A crucial part of this approach is obviously feature selection. We used random forest to calculate feature importance. For symptoms, we selected most informative symptom features, and for genes, we selected 300 top 300 genes. This step is really important because it removes noise and reduces computation, especially for gene expression data where thousands of genes may not all contribute to this classification. After feature selection, we tested baseline machine learning models, including support vector machine, random forest decision tree, and logistic regression. And finally, we evaluated our proposed model, which is designed to learn complex patterns from selected features. The overall idea is quite simple. First, we select the best features and then apply deep learning approach. So random forest selects the most important inputs, and the MLP learns non-linear relationship across multiple layers. Here, ReLU activation helps the network learn complex patterns efficiently. And finally, in the final layer, we use the softmax to output class probabilities for multi-cancer classification. So if I have to summarize the whole architecture in 3 steps, I would say first, random forest based feature selection. Second, multiple hidden layers to capture deep patterns. And third, a softmax output for final multi-class prediction. If we look at the results, you can see for symptom-based classification, traditional models produced accuracy in the range of 63.98% to 96.91%. Among these, random forest was the best baseline model, which achieved 96.19% accuracy, but our DMLP net architecture achieved 98.08% accuracy with the precision recall and F1 score close to 0.98. Secondly, if you look at our gene-based classification, you can see the models achieved around 71 to 92% accuracy, where our proposed model achieved 99.29% accuracy with precision recall and F1 score close to 0.99. To conclude, our we proposed two-stage multi-cancer classification framework using both symptom data and gene expression data. By combining random forest feature selection with a deep learning multi-layer perceptron network, the system achieves very strong performance. The model is accurate and efficient, and it also has the potential applications in early cancer detection. For future work, we plan to expand datasets using multi-institutional sources, including the various kind of patient data, optimizing architecture further, expand the approach to more cancer types and molecular profiles, and move close to real-world clinical deployment for precision. So thank you everyone for listening. I'm happy to answer all of your questions if there's any.
It's a good research. So I have a few questions regarding the same. One is you're using a deep neural network, right?
Yes.
So how did you determine the depth and the number of neurons in the hidden layer? So whether it was a trial and error method or you just happened upon this kind of architecture.
Okay, what we did, random forest was giving the best result among the baseline machine learning models. So we took it and we we selected 3 hidden layers because it was giving the best results. We tried 4 and 5 too, but the results are not that optimistic. So yes,
Okay.
yes.
So for LSA learning like LSTM, which for this kind of data.
I'm sorry, I couldn't hear you.
So have you tried any deep learning method like LTM, which can work with this kind of data?
Actually, we tried that too, but as I said, the results are not that good. But um, we are planning to use various kind of deep learning model in this too to see if the result, if to see if we can achieve more good result.
Okay. Clarification I wanted was, so you are using two different types of data set, right? The symptom data set and the gene data set. So are you combining the results of both or the results are independent of each other?
The results are independent with each other, as you can see. Our symptom-based accuracy are distinct, and the gene-based accuracy are, yes.
So can we combine the results of the two and whether we can achieve a good accuracy with that?
Uh, yes, that will also achieve a good result. We tried that on our university thesis too, and the results were also very good.
Yeah. Thank you.
Thank you,
Thank you.
sir. Now we are moving towards the next presentation. For the next presentation, I like to call Kiran Suryakumar K for the paper title Architectural Design and Implementation of Ingrain Innovation Financial Transaction Through Blockchain Technology. I request the presenter to kindly proceed with their presentation.
Am I audible?
Yes, sir,
My
you are
screen
audible
is
to
my
us.
screen and audio is clear.
Yeah, both are clear. You can proceed. Thank
So,
you.
for, so first I want to thank SMARTCom 26 for giving this opportunity to present our paper. So I'm Kiran Suryakumar. Today we are going to present our work called Architectural Design and Implementation of Ingeon, Innovating Finance Transaction through Blockchain Technology. So our paper ID is 336, and then I'm here representing all my co-authors behalf of. First, I would like to share the quote given by Satoshi Namato. He is the main founder of the blockchain. If he isn't, there is no blockchain now. So I would like to see the quote is: blockchain is not just a technological shift; it is a societal test for trust and adaptability. So as he said, as blockchain is a new technology for this current era, and we are currently in the phase of trust dilemma. So since if we break through this trust dilemma, blockchain would become the uh, main spine for all the existing technologies. Ingrion is a blockchain financial ecosystem that establishes a unified platform in a network for market and decentralized finance. It is mainly tailored for IPOs and FPOs, and then we have created Ingrion mainly for conducting capital markets as it before the secondary markets for conducting IPOs and FPOs, and then we have tried to incorporate the throughputs of UPI, Unified Payment Infrastructure of India, to get the same throughput in this blockchain. Then we have satisfied this. So Ingredient supports P2P and B2B lending. Lending unlock new liquidity channels by allowing assets to serve as collateral. Native Smart modules coordinate market operations, corporate finance, and DeFi activities seamlessly, while regulators can enforce policy, taxes, and compliances in real time. By bringing all these elements together into one programmable, trustless infrastructure, Ingredient creates a complete, flexible, and scalable financial ecosystem. So Ingram incorporates of capital markets, DeFi lending, corporate finance, plus compliance in one programmable system within governmental oversight. The current problem with the blockchain for this purpose is that there is not a single specified system for handling IPOs and then regulators. This is blockchain is made for decentralized with trustless. So there is no single power for regulators. So there is no current system with that. So we have to gain the trust of the users. Uh, we have incorporated regulators of government, SBOA, uh, Stock Exchange Board of India. So that brings in reliability and trust for the current Indian users. So a traditional financial ecosystem includes IPO, stock exchange, and daily backing, centralized authorities creating risk of misuse power, manipulation, and lack of transparency. And FPOs often experience underpricing, oversubscription, and opaque allocation practices, leading to unfair advantages for certain investors or institutions. Corporate transactions such as dividend distribution and refunds are slow, error prone, and difficult to audit in real time. Daily transactions including P2P transfers, lending and payments are constrained by intermediaries. High fees and delayed settlements, moreover, regulators' oversight is often reactive rather than proactive, and manual enforcement of policies can create bottlenecks. These challenges highlight the need for secure, transparent, and programmable financial ecosystem that can be handled both capital markets and everyday financial activities. So the main objectives of the blockchain named Ingrion is to create a transparent capital markets, enabling secure and auditable IPOs and FPOs and corporate finance. And an efficient transaction supports instant and low-cost transfers of tokenized cash and investors and companies. Def- DeFi integration, decentralized finance integration, provides B2B and B2B lending using networks asset as collateral, unlocking liquidity, regulator compliance. allow real-time enforcement of policies and taxes and market regulations through on-chain models, flexible and innovation, of a platform where users and regulators can adapt, propose, propose changes, and implement new financial ideas. Its secure and scalable ecosystem build a trustless, resilient network of validators and regulators, nodes with native smart modules for core market operations. The main features of Ingion is that it has native smart contract, whereas other blockchains as Ethereum and Bitcoin has an Ethereum EVM for executing the smart contracts, which runs in a single thread and has bottlenecks of running multiple operations at the same time. So we found that issue, and then we have made every smart contracts to be running as a native smart contracts, which can run on a system's multi-thread. So uh, this gives the efficiency of processing more transactions per second, and then increasing the throughput of the network. So native smart contracts for market operations automates IPO FPO processes, including TRHP and RHP submissions, book building, share allocation processing, and dividend distribution. Integrated KYC and wallet provisioning. There is no KYC ever done in existing blockchain, so we saw that problem and then integrated in this network. So using a government issued expirable KYC link combined with client-side physical embedding to securely generate and register wallets without storing sensitive data. We are using a physical embeddings and API links from a government portal to register in the main website, mainnet of the blockchain to create the wallet and then account. So once the only with the person with KYC cleared can open and use the blockchain for transactions and participating in an capital market. Tokenized company shares as collateral enables P2P and B2B lending with company shares as collateral, unlocking liquidity for investors and companies. End-to-end IPO and FPO management conducts complete public offering transparently from regulators filling to post-allocation settlements, which is like running a full IPO without a centralized power or any overlook. It's fully encoded and then editable as per the regulator or policy changes. It's decentralized finance lending, facilitates lending and borrowing using tokenized assets, integrating market operations with financial flexibility. User the main part of the blockchain is to user driven flexible ecosystem, supports users and regulators driven innovations, allowing process improvements and future extensions. The existing capital markets rely on multiple intermediates, underwrites, book, brokers, and registers, clearing houses. IPO and FPO process are manual, involving document verification, offline investor handling, and late settlements. Data and workflows are centralized, resulting in low transparency and slower operations. The limitations of the existing systems are slow processing, settlement cycles takes a transaction of 2 to 3 days, delayed refunds, and then inefficiency liquidity. High cost high cost transaction fees up to 11 to 15% of the whole IPO conducted, and restricting access for small investors and startups. Poor transparency, post facto regulatory enforcement, manual audits and fraud risks, low automation, high risk of errors, delays, and low scalability. Weak technology, no support for decentralized trust, automated compliance for high frequency operations.
Sorry to interrupt, sir, but you have 1 minute to conclude. Thank
Yes,
you.
thank you. This is the illustrative comparison. The traditional IPOs, an example. This tableized the example of traditional IPOs and then IPOs conducted in a blockchain. The example we are the cost paid for this IPO is more, while if you conducting in blockchain is very less. So for a single share, in traditional IPOs takes up to 2 to 3 rupees per share, while as in conducting an Ingredient it takes up to and a half paise to 1 rupees. The whole Ingredient is built on Go Go language. So everything is a Go language is mainly built for concurrency, and Go routines are used for running concurrency functions. So which is the main uh, soul of Ingredient, keeping it running in concurrency. The network's throughput is 9,500 transactions per second, and then this is the same throughput for the Indian UPI. So the current system can translate easily into blockchain technology. This is the architecture of Ingrion. The company need to the company or users, everyone need to complete the KYC, and then they will get registered, and then all the nodes will have the copy of the addresses, and then the company submits the RHP, and then regulators approve and give the RHP, and then all the users can see the data from the net from the chain. So there is nothing from off the chain, everything is incorporated inside the chain. So there is an severe trust reliability for everyone. And then after once the every there is an allocation engine and IPO engine for automating the whole process in blockchain, which is executed by each nodes in batch wise. Conclusion: Indian blockchain network demonstrate how capital market specific IPOs automated and made highly efficient using decentralized technology by integrating uh, privacy, privacy and efficient KYC, client-side value generation, and native IPO smart contracts. The system eliminates intermediaries, reduce operation cost, and accelerate settlements. At the same time, regulators oversight through POA nodes ensures compliance and trust without centralizing control. With high throughputs, deterministic conscious, and real-time bit allocation, Ingredient provides a scalable, secure, and transparent platform that balances decentralization, privacy, and governance, paving the way for next-generation fundraising solutions while significantly lowering costs for companies and enhancing accessibility for investors. Thank you. So I'm ready for answering the questions.
You did not mention what kind of network are you using, whether are you using Ethereum or any other blockchain. Can you
Yeah,
hear me?
Ingredient is an integrate is an whole new network. So the nodes or everything is fully developed for this. So we can't use the existing network because there is no regulators. If regulators are introduced, that breaks the decentralization. So we are made in the way that introducing regulators won't break the decentralization. So
So if you're
we are created a
creating
new network for that. So we are creating a new
your
network
own,
for that.
if you're creating your own blockchain, then the management of the blockchain. So if
Sir,
you're using your own blockchain, okay, you're
yes, sir.
creating your own blockchain, then how are you proposing the network work? How will be the data distribution work? How will the smart contract work? So these information.
Sir, everyone, the main website will be hosted by the government. So which must be hosted by the government because it's the current process of capital markets are undertaken by the government. So that gives trust for the other users. So if from that completing the KYC, everyone can download the software from that website, and then they can join the network as what happened in Bitcoins and other Ethereum networks. And then there are the smart contracts are native. So if there is new contracts, they can apply through they can write the network, they can write the code for the smart contract and submit it through the portal. So once it verified, and then that can be added to the network by the regulators. So it gives safety for everyone. And then all the smart contracts are not run through EVM, which is a Ethereum virtual machine. So it's all contracts are run in the system threads. So it gives fast. So the all smart contracts can be executed very fast. That's it. I have answered the questions.
Thank you, sir. I request session chair, sir. Sir, do you have any questions? So let's move to the next presentation. For the next presentation, I like to call Rashmi Kamlakar Dixit for the paper title Deadline Aware Resource Allocation for Periodic Edge Tasks in AWS Cloud. I request the presenter to kindly proceed with their presentation.
Yeah, sorry for that. Can you hear me now? Uh,
Hello,
yes, please go on.
my screen is visible.
Yes, ma'am, but we are not able to see your PPT. We are able to see your Zoom meeting screen. So please,
Now,
not yet, ma'am. Ma'am, please share your entire screen, then you will be able to shift to your presentation.
okay, please confirm now.
Yes, ma'am, now it is visible. Please continue.
Okay. Thank you first of all, SMARTCOM, to give this opportunity to present my project in front of you. Good morning, respected chairs and professors and researchers. My name is Komal Dandkare. This work is authorized by me and Dr. R.K. Dixit from Walchand Institute of Technology. Today I am pleased to present our paper titled Deadline Aware Resource Allocation for Periodic Edge Tasks in AWS Cloud. This work is focused on intelligent and cost-aware task offloading for real-time edge cloud system. I will walk you through the motivation, proposed solution, and result of our study. This is outline of my presentation. I will be being with brief introduction of the motivation and behind work, followed by the key challenges edge cloud system. Then I will summarize the abstraction and explain the need of the project. After that, I will present the proposed solution along with the system architecture and workflow. I will also demonstrate a real-time example to show how tasks are scheduled and processed. Next, I will explain the feasibility checker
Uh,
logic.
Ma'am, sorry to interrupt, but your presentation is stuck on the first page. Can you please move your slides or either move, like change it into the presentation mode?
Okay. Now it's visible.
Yes, ma'am. Please continue.
Yes. This is my index page where I will be first being with my introduction and motivation behind the work, followed by the key challenges and edge cloud system. Then I will summarize the abstract and explain the need of the project. And after that, I will present the proposed solution along with the system architecture and workflow. I will also demonstrate a real-time example to show how tasks are scheduled and processed. Next, I will explain the feasibility checker logic, cloud execution and monitoring approach. Finally, I will discuss this result, benefit and conclude the future scope. Now I am moving to the introduce and motivation. In recent years, smart systems such as IoT devices, sensors, and surveillance systems have become widely used and generate large amount of real-time data. These systems rely on edge devices like Raspberry Pi because they are low cost, portable, and close to the data source. However, edge devices have limited computational resources and cannot always handle computational intensive or time critical tasks. Cloud computing offers powerful processing capabilities, but offloading every task to the cloud increases cost, latency, and bandwidth usage. Therefore, the key motivation of this work is to design an intelligent system that decides when to execute tasks locally and when to offload them to the cloud, while ensuring deadlines are met and cloud cost. Now I'm moving to the challenges of my project. There are several key challenges in edge cloud system. First, edge devices such as Raspberry Pi have limited CPU and memory, which makes it difficult to execute computational intensive tasks locally. Second, real-time applications have strict deadline and missing this deadline can lead to incorrect or unsafe system behavior. Third, cloud execution introduces additional cost and uncontrolled offloading can quickly exceed budget limit. Fourth, network bandwidth between edge and cloud is often limited and unstable, causing delay during task offloading. Finally, many existing systems lack intelligent decision making and either offload tasks blindly or use static rules. These challenges highlighted the need of the smart, deadline aware offloading framework, which motives our proposed solution. Now I am moving to the abstract. To summarize our work, smart systems continuously generate real-time and periodic tasks at edge devices. Although edge devices like Raspberry Pi are efficient and low cost, they have limited computational resources. Similar offloading all tasks to the cloud is not an effective solution as it increases the execution cost and bandwidth usage. To address this, we propose a deadline-aware offloading framework, intelligently decide where tasks should be executed. The system uses rate monitoring, scheduling, and task grouping to effectively prioritize periodic tasks. A feasibility checker ensures that only tasks which satisfy both deadline and cost constraints are offloaded. By using the AWS free tier services, the solution achieves cost-effective execution while improving responsiveness and deadline adherence. What is the need of the project? Smart systems such as industrial monitoring, surveillance, and environmental sensing require timely and predictable responses. In this system, delayed execution can reduce performance or even cause system failure. Although cloud computing provides powerful resources, cloud services are costly, especially when tasks are offloaded without proper decision making. Additionally, network bandwidth between edge and cloud is often limited and unstable, which can further impact performance. Therefore, there are a strong need for the smart decision system that can balance deadline requirements, cloud execution, cost, and bandwidth availability. These needs form the core motivation behind the proposed deadline-aware offloading framework. To address the identical challenges, we propose a deadline-aware task offloading framework designed specially for periodic real-time edge tasks. The solution followed an edge-first decision-making approach, where the edge devices initially evaluates whether tasks can be executed locally. Tasks are first grouped and prioritized using the rate monitoring task and ensuring the time-critical task receives higher priority. Next, feasibility checker evaluates delight feasibility, CPU resources, bandwidth conditions, and estimate cloud execution cost. Only tasks that cannot meet deadline locally and cost feasible of offload through the cloud. To maintain the cost efficiency, the framework uses AWS free tier such as Lambda for lightweight tasks and EC2 for higher workloads. By combining schedulability with feasibility checker, the process solution ensures timely execution while maintaining cloud cost and bandwidth usage. Now I am moving to the system architecture. This slide illustrates the overall system architecture and workflow of the proposed framework. The process being at the edge devices Raspberry Pi, where periodic real tasks are generated from the sensors and applications. These tasks are first grouped based on the shared characteristics or data overlap. Next, the group tasks are prioritized using the rate.
But you have 1 minute to conclude. Thank you.
Thank you. Um, After that, feasibility checker then evaluates whether the task can meet deadline, constraint, bandwidth, and estimate cost. Based on the decision, tasks are either executed locally or offload to the AWS cloud. Finally, execution results are stored in S3 and DynamoDB for the providing feedback for the system performance. This is the real-time example where its primary role to determine whether a task should be executed locally and edge upload to the task. First, it evaluates the local CPU ability, estimate execution time, checks the task can meet the deadline Raspberry Pi. After that, only when the task fails local feasibility but satisfies the cloud feasibility condition, it is offload. Here is image processing task receives the higher priority due to their short execution period. The feasibility checker determined that this task cannot meet deadline locally and intelligent offload to the AWS cloud. There are results and benefits. The proposed framework demonstrates several important benefits. First, it satisfies the reduced deadline missing by prioritized time critical tasks using rate monitoring scheduling. Second, feasibility checker minimize unnecessary cloud usage leading to lower execution costs. Third, task grouping and intelligent offloading helps reduce bandwidth communication. Overall, the system achieves better responsiveness, cost efficiency, and predictable performance compared to the traditional blind offloading approach. This is my conclusion and future scope. To conclude, this work presents a smart and adept edge cloud collaboration framework for real-time periodic tasks. The proposed solution ensures deadline-aware execution while maintaining cost-effective and scalability using AWS free tier services. By combining scheduling and feasibility-based offloading, the system achieves reliable performance under the resource constraint. Future scope: as future work, the system can be enhanced the dynamic bandwidth prediction to improve offloading design under varying network conditions. More advanced scheduling strategies such as hybrid and adaptive model can be explored the better performance. Thank you. This is my
So,
reference.
yeah, okay. So can you go back to the results slide? Yeah,
Okay.
results.
Yeah.
So you have mentioned that high deadline success rate. So what was the actual success rate, if you can tell me in numbers?
Means currently we are using the static task which is having the static time. So there is high deadline means there are tasks which executes at limited time. So our
Okay.
system performance is
So
maintained.
do you think this is scalable to runtime operations?
Yes, yes, it's scalable. We can use.
Uh, so what is the latency for your decision logic? So you will take a decision whether to
Uh,
run it locally or on the cloud, right? So what
yes.
is the time taken to decide this thing?
Basically, we use this to decide, take a decision, a feasibility checker to take a decision.
So what is the time that is required by your logic to decide?
It is
Because when
basically
we are talking about real-time operations, there will be many transaction and many uh, tasks which will be scheduled.
yeah,
So I want to understand, have
yeah.
you looked into this?
Yes. It means
When there are high number of tasks which have been allocated or which have been decided upon. So what is the time latency for your decision logic?
the decision latency is very low because the offloading decision is made locally at the edge device using lightweighted feasibility checker without content the cloud. So it's very low. It depend on task. Means for image work, camera for image processing, it takes time, so we offload it to the cloud, and which does not have many it less time. Then we offload that in local machines.
Okay, okay, thank you.
Thank you.
Thank you. Now we are moving towards the next presentation. For the next presentation, I like to call Debusmita Chaudhary for the paper title Digital Twins Evolution, Challenge and Sustainability. I request the presenter to kindly proceed with their presentation.
Thank you.
Ma'am, you can proceed sharing your screen.
Good morning, session chair and my fellow researchers. My name is Deboshmita Chaudhary. I am from Sikkim Manipal Institute of Technology. Today, I'll be presenting our paper titled as Digital Twins, Evolution, Challenges and Sustainability. This work explores how digital twins are evolving from simple models to autonomous systems and specifically how we can measure their sustainability and privacy risks. Here is a brief roadmap of my presentation. I'll start by defining the core concepts and I'll continue and introduce the novel contributions we made in this paper. So, what exactly is a digital twin? It is often confused with a simple 3D model or simulation technique, but uh, there is a critical distinction. Here, as we can see in this figure, there are three main constructs: digital model, digital shadow, and digital twin. Digital model is a static representation like a CAD file. There is no automatic data flow. In the case of digital shadow, there is a one-way data flow. Sensors send data from physical asset to the digital twin, and the digital twin itself is the complete realization. It features a bidirectional data flow. The digital system not only receives data but can also send commands back to the physical asset to control it. This is a two-way interaction, and this is the heart of digital twin technology. This concept has come a long way since it was proposed by Michael Greaves in 2000 and adopted by NASA in 2002 for aerospace. In our paper, we outlined 5 distinctive stages of creation as shown in the figure 2. It has monitoring, mirroring monitoring, simulation, federation, and then autonomous. Mirroring is where we just build the replica, and from there we go till level 4 federation. And the concept of federation is a system of systems approach, like a smart city where traffic, power, water twins all talk to each other. And the final level autonomous is where the system self heals and it becomes robust and optimizes without any human intervention. The evolution has enabled powerful applications across various industries. The key industries are healthcare, smart cities, agriculture, also automobile industry or modeling, various aerospace engineering stuff. As we are moving toward P4 in medicine, predictive and personalized, researchers are now creating patient-specific heart models to simulate the surgery before even touching the patient to reduce the risk. Or there are projects like Virtual Singapore, where the Singapore government invested $73 million, which allows projects. So digital twin is used there to allow planners to simulate disaster scenarios or traffic flows to reduce the resource usage. For agriculture, we use it in precision farming, where optimizing irrigation based on real-time soil data is done to save water, etc. This brings us to a core theme of our paper, that is sustainability. Digital twins are not just commercial tools, they are also essential for UN Sustainable Development Goals. For SDGs 7 and 3, for clean energy and climate action, 9 and 11 for infrastructure and sustainable cities, and digital SDG 8 for decent work is maintained when we apply digital twins. But despite all the benefits, there are also critical challenges. Main are cybersecurity issues, interoperability, the cost, and environmental. The continuous data flow increases the risks of sensitive leaks. Like imagine a hacker accessing a digital twin of a pacemaker. That can be really risky for the patient. Or the lack of common protocols between heterogeneous IoT platforms. Also, paradoxically, while digital twins can save energy in the physical world, training the AI models consumes massive amounts of energy in data centers. This need to be balanced. And this is what leads us to our novel contribution. In our knowledge, existing literature often describes these challenges qualitatively. Our paper contributes by operationalizing them into measurable equations. we propose Quantitative Sustainability Index or QSI. We argue that sustainability isn't just about energy, but a weighted sum that must also include interoperability, reliability, and governance. And the weights are configurable by the industry we are using them in. For example, if we are building a twin for a green data center, we would assign a higher weight to energy. But if we are building for medical, if it's a medical twin, then there will be more weight given to governance. The flexibility shows that the index can be used across various platforms. Then we define the privacy risks as sensitivity multiplied by exposure divided by the mitigation strength. The 0.3 threshold is is a baseline threshold derived from normalizing the risk score between 0 and 1. In current risk management matrices, the lower third from 0 to 0.33 is typically considered low risk or acceptable risk. That is why we rounded off to 0.3 to provide a strict rule of thumb for developers. But future empirical studies could fine tune this number for further accuracy and better risk management. Finally, we revisited the maturity model. Most existing models for digital twins stop at level 4. But we argue that autonomy without oversight is dangerous. Therefore, we are introducing a novel level 5 for governance and ethics. At this level, the digital twin is not just self-optimizing, it includes data audit trails and explainability modules, which will ensure the black box nature of AI will be remaining transparent to and accountable to the human developers and to the users. From this, I can conclude that digital twins are shifting from theoretical concepts to practical high-value tools. However, the black box nature of AI and the privacy risks are major barriers. Our work addresses this by moving from descriptive analysis to quantitative equations for QSI and PRI. We believe that integrating these matrices into the governance layer can be the key to making digital twins not just smart but secure and sustainable for our future. Here are the key references used here in the presentation, and the full list of references is available in the paper. Thank you.
Yeah, that's a good research. So, you listed some difficulties and challenges that are there in the current systems, right?
Yes, sir.
So how is your proposed system able to, overcome all the challenges, or you are only targeting a few of them?
I am just targeting the main two challenges. As you can see here, the main two challenges I am saying as this risk and the environment. As I am saying, it can be sustainable using digital twins for everything, but also training the AI models can be risking our environmental resources. That is why we are doing for the sustainability and privacy risk first.
Okay. Uh, so, have you tested this, whether you are on theory, on paper, it is fine. Theoretically, it is fine. But practically, whether this is implementable and you are actually able to reduce the energy consumption and you are able to increase the privacy.
We have yet to test them in live dataset, but in my upcoming work on accident prediction using digital twins, we are planning to use these metrics to verify these equations.
Okay. So, okay. Yeah. Thank you. Your work is good. Thank you.
Thank you, sir.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I like to call Chinmay Prabhu for the paper title Enhancing E-Learning Evaluations Through Probabilistic Network Models. I request the presenter to kindly proceed with their presentation.
Hello, is my screen visible?
Yes, sir, your screen is visible to us. You can proceed. Thank you.
My slides are visible, right, sir?
Yes, sir.
Is it visible, sir? Am I audible, right?
Yes, sir. Both are fine. You can continue. Thank you.
Thank you, sir. Good morning. This presentation is based on my paper titled Enhancing E-Learning Evaluation Through Probabilistic Network Models. The focus of this work is on improving how student knowledge is evaluated in e-learning system by handling uncertainty using probabilistic reasoning. The goal is not to replace teachers or exams, but to support fair, adaptive, and efficient assessment. These are my contents of the paper. So we'll start with how I came for the problem statement. In e-learning system, evaluating student knowledge accurately is difficult because learning happens remotely and without continuous teacher observation. So traditional written examination are time consuming, sometimes static, meaning that the same test is given to all students regardless of their learning levels. These exams assume that correct answer always means correct understanding, which is always not true. So student may sometimes guess answers, make careless mistakes, or partially understand some concept. Therefore, we traditional exam cannot handle uncertainty. So the motivation came as students learn at different levels, different speed, and have different strengths and weaknesses. A single fixed test cannot fairly evaluate all the learners. Also, knowledge assessment naturally involves uncertainty, especially in online environments. Probabilistic reasoning is suitable because it will allow us to represent knowledge as degree of confidence instead of yes or no. The key idea of the paper is the central to represent student knowledge using probabilities. Instead of saying a student knows or does not know a concept, we estimate how well the student knows it using a probability value. A probabilistic network is used to model the relationship between concepts. As students answer questions, their knowledge probabilities are updated dynamically. So this allows faster assessment while maintaining high accuracy. So what exactly is probabilistic network? A probabilistic network is graph-based model designed to handle uncertainty. In this network, each nodes represent a learning concept as well as edges represent the dependencies between the concept, meaning understanding one concept influences another. Each node stores a probability value between 0 and 1, representing confidence in student understanding. So as student answers these questions, the probabilities are updated using probabilistic inferences. So example, we can say correct answer increases probability of the concept mastery. So why probabilistic network for e-learning? Student knowledge is not binary. It cannot be accurately represented as simply known or unknown. So probabilistic network can handle guessing, mistakes, and partial understanding. They this they infer hidden knowledge states based on observed answers. This enables adaptive questioning and personalized evaluation, making the assessment fairer. So this is the proposed architecture of the IES. So the diagram visually explains how the system works. First, the student interact with the system through the interface by answering the questions. These responses are sent to the core system where the student model stores current knowledge probabilities. The probabilistic network in the knowledge assessment module updates these probabilities based on the responses. The tutoring model then decides the next questions or difficulty level. Finally, the feedback is provided to the student completing one assessment cycle. So the methodology begins by identifying learning objectives. Questions are then designed using Bloom's taxonomy to cover different cognitive levels. A probabilistic network is constructed to model concept dependencies. Adaptive assessments are conducted and student knowledge is inferred probabilistically. Finally, feedback is provided and students are classified. So this is the methodology diagram. This figure shows the complete development process. It starts with needs assessment to understand student and educator requirements. Next, system design and probabilistic modeling are carried out. The system is then tested, validated using real student data, and improved continuously. This ensures reliability and correctness of the proposed system. Next, we'll see about the Bloom's taxonomy mapping. Bloom's taxonomy is used to ensure that assessment is educationally meaningful. Questions are distributed across knowledge, comprehension, application, analysis, and synthesis level. This ensures that system evaluates both basic recall and higher order thinking questions or skills. This structured approach improves the assessment quality. So, adaptive questioning process, how exactly this happens? Questioning can be either in consecutive or random order. After each student responds, the probabilistic network updates the student's knowledge probability. If probability is high, the system moves to a higher difficulty level. If probability is low, additional questions are asked at the same level. This adaptive process allows accurate assessment using fewer questions. So this is how the student classification is done. Based on the probability score, students are classified into three categories. Senior students means they are their score is above greater than or equal to 8.5. Normal students are between 7 and 8.5, and unequal students score below 7. These classifications are compared with written exam results for validation. So this graph shows the concept-wise knowledge estimation. The x-axis represents the learning concepts and the y-axis represents the probability of the mastery. The solid line represents a selected student while scattered point represents all the students. This clearly shows that probabilistic network infers individual understanding across concepts. The proposed system achieved an assessment accuracy of 95% when compared with written examination. Time required for assessment was reduced by about 61%. On average, only 2 questions per concept were sufficient to infer student knowledge accurately, and results were closely matching to the traditional exams. So these were the key observations. As student with higher attendance showed better concept understanding, group study improved the performance in complex topics. Probabilistic network provides clear insight into strengths and weakness at the concept levels. So these are the advantages of the proposed system. The system supports adaptive assessment and handles uncertainty effectively. It reduces evaluation time and provides a personalized feedback. It is aligned with Bloom's taxonomy, making it educationally sound. So this is what I conclude with. In conclusion, the probabilistic networks are effective for evaluating student knowledge in e-learning systems. The proposed approach achieves the high accuracy with reduced assessing time. It supports fair, adaptive, and personalized evaluation and is suitable for intelligent tutoring systems. So there are future work for this. Future work will include integration with learning management systems, real-time adaptation, scalability, and hybrid models combining probabilistic reasoning with deep learning. Thank you. I am open for questions, sir.
Yeah, so you are generating the questions that is asked to the students, or you have a set of questions and you're asking from.
Sir, I didn't hear you clearly, sir.
So you
Hello,
are
sir.
asking the question, the students are taking an assessment, right?
Yes,
So
sir.
you are generating the assessment questions based on the Bloom's level, or you are there are a set of questions which are already there and you are picking from them.
I have taken total 7. So in the Bloom's taxonomy, you can see, sir, I have taken about 760 questions. Means we have taken in which knowledge is have again 200 questions, comprehensions have 150 questions, application type are 110, analysis are 180, synthesis types are 120 type questions.
So
Using Bloom's.
you are pick, yeah. Go on.
Yes, sir. Yes, sir.
So you're picking the questions from this set and you're asking the students, right?
Yes, sir.
So don't you think like the technology has evolved and using generative AI models like ChatGPT or Gemini, this would be much faster and less time consuming?
Sir, here I'm not training or anything, sir. I'm just with few sorts of questions also we can understand about their this, sir. But other things they require more number of questions or data like that, sir.
Okay, okay, fine, fine. Thank you.
Thank you, sir.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I like to call Mansi for the paper title Geopolitical Factors Shaping the Future of Cyber Domain, a perspective to understand national cybersecurity with measures for making it operative using artificial intelligence. I request the presenter to kindly proceed with their presentation.
Thank you, sir.
Ma'am, you can please proceed.
Yes, sir. Yes, I'm sharing my screen. I hope my screen is visible.
Yes, ma'am, your screen is visible and you're audible too.
Yes, thank you so
Thank you.
much. Yeah. Respected jury members, respected SmartCom conference authors and editors, respected all the fellow colleagues who are present with me in this link. A very good morning to everyone. The paper title for my today's presentation is Geopolitical Factors Shaping the Future of Cyber Domain, a perspective to understand national cyber security with measures for making it operative using artificial intelligence with my guide, Dr. Meenakshi Mori. We are from MES IMCC, Pune. The paper agenda covers following topics: introduction to the domain, cyber geopolitics and emerging threats, factors affecting geopolitics of cyberspace, homeland security, which is a national security and it is a need of an hour, milestones for Indian cybersecurity, national cybersecurity evolution, artificial intelligence. This is the key for future cybersecurity amplification, which is very necessary, proposed methodology, pilot study, and conclusion. So, geopolitics is growing in the 21st century, and there are various factors involved, and it is hindering the peace of the nation. National cybersecurity is utmost important, and the large scale of destructive and major footfalls we are seeing in nowadays as large cyber crimes are happening all around the nation and internationally. Geopolitics plays a major role as we need to tackle the advancing challenges encompassing the economic and means of security to understand cyber domain with respect to international relationships as well. And these geopolitics focuses in this paper for homeland security, for national cyber security, with reference to past frameworks and new present scenarios. So the emerging trends for cyber geopolitics is every nation should strive for global dominance and it is always a survival for fittest. relationship which occurs every international front. It should have a global race for sovereign dominance, and it should also see for cyber crimes and attacks happening all through the factors. Cyber criminals are aiming to cause disruption, to decentralize and destabilize the economical growth of every nation. The concept of digital divide and rule is becoming prevalent nowadays. So the example is the Ushahidi digital platform, which was evolving to improve the connectivity and the digital inclusion all over the globe, but it was disruptive and there was a cyber attack into it. So we should together factor for contribute to the national cyber security, its safety, its endurance, and we should see that the rise of cyber terrorism will not be there in the future front if the nation needs to be uh, in front of Vikasit Bharat. The factors affecting the geopolitics of cyberspace with respect to my literature review focuses on the human life, economic systems, warfare and defense, strategic development, and infrastructural development. I will give a walkthrough one by one. The human life hindrances of cyber terrorism by the changes of nation to nation. People is an asset for every nation, and these people are being hindered by making it their cyber crime, making hindrance in their cyber social media, their focuses on the infrastructural way everywhere, rather it be an human or economic or infrastructural. People is an it is an asset, and that asset is being used for cyber crimes. The best example is the COVID-19 syndrome. The cyber attacks were made on all healthcare sectors, and the motto was ransomware attacks, or the monetary term that they can take. Economical systems are shaping the future of geopolitical nature of cyberspace. So economical factors play a significant role where digital trade and agreements should be stronger. Digital sovereignty is very important. It should be robust. Technological and innovation trends should be used, and it should be challenged everywhere. And cyber espionage is utmost important for economic systems. Next, it is for warfare and defense. So for warfare and defense, it is an utmost important because every nation safeguards its territory. But what about the digital dominance? Digital dominance and digital footprints are not being safeguarded. It is also utmost important. So cyber warfare arises the question as government agencies, which government agencies should primarily focus or should be responsible for using the internet. The USA has decided that it will be favor the military and the biggest infrastructure for legal parameters with respect to cyberspace. But for India, we should have an appropriate parameters to which authority should be given the surveillance of the cyberspace. The cyberspace remains intact and should be safeguarded for the cyber warfare and its defense, because it is the largest threat and it should be tackled into a possible way. Next is the strategic development. The strategic development has been expanded in the digital era. Digital warfare is encompassing the avenue of every sector, may it be medical, education, electronic, manufacturing, any particular society. It depends upon the internet uses. So cyber security is at risk. So there should be a strategic policies. We have IT acts and different acts, but its resilience is utmost important. Vulnerability should be shielded. Infrastructural development is important. So for infrastructural development, there should be policies and governance framework. It should be innovation and collaboration with different agencies so that your infrastructural development and national development will be safeguarded. Government should fund Indian cyber security implementation projects very particularly. Participation in public cyberspace should be scrutinized. It should be diligently looked, even if you are using any login ID or password for any institution or organization. Intrusion detection should be important. Its firewall should be utmost important for infrastructural development. There is a need of homeland security and national security as cyber terrorism is involved it is disruptive and destructive in any ways. India needs a redesign in counterterrorism and infrastructural areas for legislative ways. So it should possess challenges for government and law enforcement agencies. The objective of Homeland Security is to weaken the national security across multiple domains. So we should safeguard it with various finance operations. We should train all the members from the schooling age itself. We should plan and execute different types of attacks from our side where their attack should be defended. Major terror attacks that had been used in my study, that was 9/11 attacks and 26/11 Mumbai attacks, where there were a major use of internet usability also, where using our internet, our TV and everything, they were able to see what is happening here and they can withhold our authority by using the attacks from their front. The example of cyber espionage is allegedly cyber attacks for Indian vaccine manufacturer, where they were developing the COVID-19 vaccine, but Bharat Biotech and Serum Institute had an attack where Homeland Security was disturbed. So the milestones for Indian cyber security, which I put forth, is Vikasit Bharat and national security. As India is going for the developed nation, we should have a counter-terrorism challenge. It should have an institutional reforms framework. There should be a persistent external threat which is there. It should be safeguarded. Cyber terrorism on a national front, as I have discussed, using an internet and infrastructural and intrusion detection and firewall should be safeguarded from minute stages also. Strengthening cyber security infrastructure. There should be good
Sorry to interrupt,
regulatory.
ma'am, but you have 1 minute to conclude. Thank you.
Okay. Intelligence and law enforcement, cyber security, defense sector, cyber awareness, and cyber security. National cyber security evolution, I will go fastly. To 2004 to 2023, it is from security policy to legal reform. Artificial intelligence and cybersecurity amplification, that I am using AI. I am introducing, it is starting from enhanced detection, network protection, anti-phishing measures, robust authentication, behavioral analysis, and defending cybercrime. Proposed AI model should have threat detection, anomaly detection, and an incident report. And this incident report should have data privacy, its compliance, threat detection, mitigation, scalability, live tracking, alert management, performance, customization, and there should be a cost effectiveness framework. My study gives of 1 lakh data set of public data sets that are available on DARPA and military agencies. So the study shows that the attack type that are mostly used is malware, intrusion, and DDoS. It is scaled from high to low, starting from severity range to medium range, from 4,300 to 4,399, and going to a low of 3,900 to 3,999. To summarize it, I can say that malware attacks are the most disruptive attacks and it should be safeguarded in any which ways. I conclude that rising cyber crimes with rapid digitization, digital and data privacy are critical. Cybersecurity should be strengthened on national and geopolitical level. AI-powered intrusion detection framework should be there. Pilot study shows that AI predicts and prevents cyber attacks. So more AI-related framework should come into the market and should safeguard it. Early AI implementation will boost national resilience, and we will move towards India to be a Vikasit Bharat. These are the references, major references I have cited in the paper that I have submitted. Thank you so much. I'm open for discussion and question answers.
Yeah, I largely agree with the conclusion that you have. So, yeah, uh, yeah, good book.
Thank you, sir.
So we are moving forward. For the next paper title, I like to call presenter Tanish for the paper title IoT-based happiness index prediction for employee workability towards sustainable growth, a comprehensive review. I request the presenter to kindly proceed with their presentation.
Yeah, thanks a lot.
Thank you, sir. You can proceed with your presentation.
Is my presentation visible?
Yes, sir. Your screen is visible to us.
Yes.
You can proceed.
Good morning, everyone. I'm Tanish Virmani. I thank to all the session chairs, the host, and all my researchers. For the SmartCom 2026, my paper title is IoT-based happiness index prediction for employees' workability towards sustainable growth, which is a comprehensive review. These are the authors. I would like to start with introducing you to the core idea. The core idea is employee happiness is directly linked to the productivity, retention, and organization's sustainability. How well an employee can work is directly proportional to how active he is mentally, and that we are analyzing through emotions. With the technologies and increasing workplace stress and hybrid work models, traditional assessment methods are insufficient. They duly lack due to false positives increases. And this study reviews IoT-enabled system combined with machine learning and deep learning models to predict a quantitative happiness index. The contribution of this work includes which reviews IoT plus ML approaches, which analyzes models, datasets, and performance, and highlights gaps and futures for sustainable growth. I would be moving to why are we choosing and background and motivation. It employee workability directly depends on mental well-being, emotional stability, and physical comfort. The previous tools were periodic surveys, self-reporting, and limitations are subjective bias, which are also low responses and no real-time feedback. There is not a machine which can guide you how emotionally stable you are and how you can overcome through it. Why are we using IoT? It enables continuous non-intrusive data collection. It captures real-time data and it also supports predictive and preventive decision making. Now we move to the identified research gaps which are currently not there. These are the research gaps which I found. Lack of real-time monitoring. Usually we need to self-monitor ourselves and then I should know that I am not emotionally stable and then I have to check myself through a therapist or a psychologist. But the model is should be capable of detecting the emotions and also predicting them accurately. Subjectivity in assessment. I do not have a reason why my emotion is sad. I just know that I am sad. Fragmented data usage. It is rarely integrated. Psychological, environmental, and behavioral aspects of a person are usually misused. And limited predictive intelligence. Many systems only detect stress but do not quantify happiness trends. So we have a risk trend from 0 to 100 when we can know your happiness index. The main question in this full research is how can IoT and intelligent model be used to predict employee workability objectively and support sustainable organizational growth? And that will be answered into the next where we go for proposed solution, where this is the system flow. The IoT will collect the images from the webcam and IoT devices, data pre-processing where the model gets trained, and happiness is predicted, and happiness index generation. This is basically the numerical model with which a generic mathematical model will help. Visualization and decision support is basically how well we are talking with the user about their mental condition. Emotion recognition model, this is the process flow. Once the input image is given, we extract the features through neural networks and then we predict its emotion. Model training process, input data, then we compute the prediction model, we calculate the loss function, we update weights. So update weights is basically how well we are calculating each aspect of the face and how accurately it will give us the emotion. Yeah. Now, literature review, we found that traditional machine learning approaches classify random forest, support vector machine, and k-nearest neighbors. We also saw that it is widely used for emotion classification, but all these models fails because some are rule-based systems. If there are rule-based system, it will obviously fail because each human is different. So we need a generic model or a generic mathematical term in which we can classify and quantify emotion and how can we detect them. Support vector machines and KNN are also like predicting if 10 emotions are happy, then the 11th person living them is also happy. But that is not actually true, where we see that deep learning models, where we use deep learning approaches like CNNs and LSTM, often show better results because they are generic model and they adapt to a person's workability. automatically extract the special features, and LSTM we have designed for time series physiological data. The reported performance metrics we found that CNN based models often give accuracy of 88 to 92% with strong data augmentation. LSTM often give 85 to 90 and which outperforms traditional rule based ML models by 8 to 12%. These are the results and discussion. So on the right we can see ROC curve. This particular curve shows us that in the particular data set, which is FER 2013 from Kaggle, this data set shows that happy and sad emotions are often very high because those are very common images and emotions found. But this green line which also shows fear, and this chart, like these five lines would also predict how a person is not being stable because we don't have particular images of that sort. We also track real-time tracking enables, which reduces burnout, improve productivity, and better employee retention. The sensor noise, data privacy, and cross organizational generalization are the challenges which are being faced in current technologies. These are the confusion metrics which actually determine when an emotion is predicted, what is the bias ratio of this particular notion. We conclude while saying that IoT based prediction is feasible and effective. Deep learning models offer superior performance. Happiness index serves as a measurable indicator of a workability. Data driven workforce, improved organizational resilience, and enhanced employee satisfaction are the main conclusions of this research. The future direction also use multi-industry datasets, federated learning, which is a key part for privacy, and integrational with organizational policy system. One future direction could also be connecting multimodals, where we include speech, like physiological data from smart devices and also text devices. These are the references. I would love any questions from your side.
Yeah, can you tell me more about the data set that you have used?
Yes, sir. So it's basically, sir, FER 2013, which is publicly available on Kaggle. This data set consists of around
Okay.
28,000 images. Predominantly happy and sad images are about 8,000 each. And the problem we faced in this case was some emotions like sad or happy, fear and disgust also, which also signify that a person is actually sad and not happy. And we come from a common emotions, and these three emotions are only 200 to 300 images. So this unbalanced data set, we made it balanced due to or data augmentation. We applied strong data augmentation by rotating, scaling, and translating images, and then we provided a clear solution for that unbalanced data sets.
So how do you justify the title of IoT-based
Yeah, yeah.
happiness prediction?
So, sir, connecting IoT with models basically enhance the workability due to real-time monitoring, sir. So, if I don't have real-time webcams, let's suppose if I'm in a classroom and I have to get my emotion, the only very true way to handle my emotion is by taking a camera and then measuring my emotion through my face. So that is the way if we apply IoT devices in let's say a classroom, and then we have a emotion of particularly all students in a class, then that would enable high scaling, sir, with reducing the false positive errors and enhancing this technology and combination of IoT with deep learning models, sir.
Okay, okay. Yeah, yeah, good one. Yeah.
Yes. Thank you so much, sir.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I like to call Ruby Bist for the paper title Mapping the Landscape, a bibliometric analysis of research on technology use and work life balance. I request the presenter to kindly proceed with their presentation.
Uh, Good morning, respected chairperson, distinguished panel members, and fellow participants. I am Ruby Bist, and I am pleased to present my research paper titled "Mapping the Landscape: A Bibliometric Analysis of Research on Work Technology Use and Work-Life Balance." Thank you for giving me this opportunity. I am now proceeding with my presentation. So, introduction and problem statement. So in today's digital era, rapid technological advancement has fundamentally transformed the nature of work. While technology enables flexibility, connectivity, and boundaries between professional and personal life, as a result, work-life balance has become a growing concern for employees, organizations, and policymakers. Technology plays a dual role in acting as both an enabler of flexible work and a source of digital overload. Therefore, understanding how technology influences the work-life balance has become an important research priority. This study maps the global research landscape on the technology use and work-life balance using the bibliometric analysis with the help of WAS library. So, literature view. So, the current literature shows that the work-life balance refers to an effective management of professional and personal roles. While changing the work practice have increased job demands and stress levels, while organizational support and flexible work policies improve employee well-being and retention, the technology plays a major role in shaping work-life balance by blurring the work-life boundaries and increasing work intensity. During the COVID-19 pandemic, teachers faced increased workload, ICT challenges, and higher work-family conflict. Excessive ICT use also led to the technological overload and reduced well-being. Although work-life balance and technologies are widely studied, but limited research applies with visual bibliometric analysis to map the research trend and knowledge gaps. So this study addresses that gap. Objective of my studies are the main objective of the study is to map the global research landscape on technology use and work-life balance over the last decade. Significantly, the study aims to identify influential authors, leading journals, and contributing countries, analyzing the conceptual structure of the field using the bibliometric technique, and detect the emerging research trends and knowledge gaps. The findings are intended to provide useful insights for the researchers, policymakers, and the organizational leaders. Research methodology used in this paper. This study uses a bibliometric analysis approaches to examine research on technology use and work-life balance. Data were collected from the Scopus database covering the period from 2014 and 2024 using the search term technology use and work-life balance. After applying the language restrictions and the subject area filters, 627 papers were selected for the analysis. The analysis was conducted using the WAS viewer, applying the citation and the keyword occurrence in text. Major representing the core intellectual structure of technology use and work-life balance research. The top cited authors, first one was Becker with 230 citations. After him, Greenhouse with 144 citation and Kosek with 137 citations emerges as the most influential scholars based on the citation counts, indicating their central role in the shaping this research domain. Next was bibliographic coupling of sources. This was conducted to identify the most influential journals in this research domain. Out of the 464 sources, 66 were selected based on the minimum publication and citation criteria, which was minimum 2 documents and 2 citations. These sources formed a major cluster representing the core publication outlets for research on technology use and work-life balance. The leading journals include the New Technology, Work and Employment, Sustainability, and Frontiers in Psychology. Bibliographic coupling of countries. This shows that the research on technology use and work-life balance is truly global. A total of 94 countries contributed to this field, and 32 countries were selected for the detailed analysis. The United States leads with the in terms of both publication and citations, with 136 papers and 3,137 citations, followed by UK, Canada, India, and Australia, respectively. These countries form a core global research hub in this domain. Next one is keyword co-occurrence network. This analysis identified 126 core keywords from more than 3,300 extracted keywords. These were grouped into 6 major thematic clusters. The dominant research themes include work-life balance, COVID-19, remote work, digital technologies, mental health and well-being, artificial intelligence, human resource management, and sustainability. The results clearly shows a strong shift in research focus after the pandemic towards the digital work practice and the employee well-being. Key findings and research trends. This analysis reveals a rapid increase in research publications after the 2022, largely driven by the COVID-19 pandemic and the shift towards the remote and hybrid work. There is a growing focus on the digital stress, technological stress that called techno stress, and the mental health and well-being, along with the emerging interest in the artificial intelligence and automating the tasks. The field has also expanded across the disciplines, particularly in psychology, management, and the social science. Limitation and the future scope of this paper. Limitations. While the study is limited to only Scopus database and the English language publications, future research can expand to the other databases like Web of Science, PubMed, and Science Direct also, and use the advanced AI-based text mining techniques. These findings provides valuable insights for the researchers, policymakers, and organizations in designing the sustainable digital work practices. To conclude, research on the technology use and work-life balance is rapidly expanding. Strong growth observed after COVID-19, especially after the COVID-19 pandemic. The bibliometric analysis reveals a strong interdisciplinary contribution and identifies the most influential authors, journals, and countries in this field. This paper also supports the evidence-based digital workplace policies. These are the references for this paper.
Yeah, so you have your major findings from the research, right? So what is the solution that you feel that are relevant?
Hello, sir, can you repeat the question?
Yeah, you have the conclusions and concluding remarks from the research that you have done. So what do you think are the solutions to your findings? Ma'am, can you hear me?
Hello.
Yeah, can you hear me?
Yes, sir.
Uh, yeah, can you hear me, ma'am?
Hello.
Is
You're
my voice
perfectly
audible?
audible. Sir, you're perfectly audible.
Okay. Ma'am, can you hear me properly?
Hello. Sir, my networks are unstable. Hello.
Yeah, my question is regarding the research that you have done. So what do you think are the solution to the problems that you have identified?
Sir, for problem related to work-life balance in the workplace, we can introduce the flexible workplace working hours in the organization. Like institutions should allow the flexible schedules wherever possible, enabling employees and to manage their both personal and professional lives. Like we can distribute the workload reasonably. We can have boundaries between their work life and their personal life, different leave policies and training.
Okay. So I feel this even the solution. So you have identified the importance of work-life balance, and that is all fine. I feel even the solutions that have been identified through different
Yes,
researchers. So even
sir, these
that
are
should be documented.
yes, sir.
Yeah. Yeah. Nice work. Thank you.
Thank you, sir.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I like to call Shweta K for the paper title Medicine Expiry and Donation System Implementation with AI and OCR Technique. I request the presenter to kindly proceed with their presentation. Ma'am, please proceed. Ma'am, you are not clearly audible. Ma'am, you need to raise your volume. Actually, we are not able to hear you up.
Am I audible now, sir?
Yes, ma'am. Now you're clearly audible. Please proceed.
Yes. And is the screen visible?
Yes, ma'am.
Yes. So, good morning. Before starting with my presentation, I'd like to thank SMARTCOM for giving us this opportunity to present this paper. And myself, Shweta K, along with my co-author, Mohita Jay, is here to present our paper. So, before presenting, I would like to thank my mentor, Dr. G. Manikandan, who is also a co-author for this paper. So today we are here to present a paper named Medicine Expiry and Donation System that's been implemented through AI and OCR. Uh, so let me begin with explaining the real world problem that motivated for this research. So first of all, we came up with this motivation by two perspective of healthcare life, where we can see that at one point there are of course many households where large amounts are being purchased uh, and being wasted, like partially used and getting wasted until they expire. For example, when a person goes to an accident and they'll be buying a bunch of medicine packets, like totally packed for around 4 to 5 months, or like the people with cancer who gets their medicine in a bunch of boxes, and like unfortunately they will not be using it for their whole lifetime. If it for 4 to 5 months, they may just stop it at 3 months, and the next 2 months medicines of will be going into waste without being opened or used with a lot of expiry date. And when they are just being disposed like in the soil, it forms many hazardous dangerous. And at the same time, there are many communities and clinics that still struggles to access to these basic medicines. So we clearly see a paradox where these medicines are wasted at one end, and where at the same time some people are in need of those medicines. But at the same time, we can also see that, I mean, like in the general situation, the medicines is risky because, like, directly delivering it to people or giving the medicines to others while they are in need, it might raise a problem with expiring dates that may not be clear, and labels that may be damaged, and the manual verification cannot be stable. So our work attempts to bridge this gap by building an AI-enabled medicine expiry and donation system that can safely verify and redistribute unused medicines. So the main objective for our work is to design a system that the first one is to automatically extract expiry dates from medicine package images like using OCR. The OCR plays a main role in our total implementing system. And the second one will be to validate whether the medicine is safe or safe to donate. It will be like always in a running process. It validates that date of one like a week based, month based, and they just categorize it to expire, near to expire, the deletes on if you want. And there is also intelligently matching verified medicines with the donors, since the donors and recipients will be along in that system. And there also will be a redistribution that works along here. So key distributions, the main thing is that OCR based expiry extraction and an AI based matching mechanism to allocate medicines to those recipients. So these are the literature reviews that we came across while working on this paper. And what we have concluded from this paper is there are mainly two things. The first one includes that there are many people who say about like wasting of medicines or discarding of this medicine that going into waste. Like it forms dangers to the soil and to the people surrounding it. And we can also reuse and such kind of things in a theoretical way. And there's another perspective of people where they have actually worked upon these works like by giving it to the nearby hospitals or pharmacies or NGOs who then redistribute the system. But this one mainly focuses on outside some developed and developing countries, but not in India. So if you see for the existing systems, we can see that medicine return and disposal rates. It's not particularly about redistributing to the people in needs, but it is about how safely we are disposing those medicines that are not in use. And as I have said earlier, there are donation platforms where we can see it in USA and some Indian NGOs, but they have not used any AI-based systems or anything. And we can also see that there are some government programs and pharmacy based who have come up with this idea. But all through the existing system, we will see that there are no AI driven platform including here. So our proposed system and the advantages of this is by creating an AI powered platform which tracks which first of all makes a OCR validation to see for the expiry date and validates if the medicine is valid or not. And we will also do a smart matching engine. It's not about GPS tracking or live location, but it's about region matching of people for cost efficiency. And that's the advantages come with the which reduces medicine wastage, first of all, our main priority, and improves accessibility and affordability. So it bridges the gap between excess household stock and people who are lacking medicine. So then this is about the theoretical part, and the architecture part will be explained by my co-author Mohit Rajay. So I'm handing over it to Mohit Rajay.
Thank you, Shweta. I hope I'm audible.
Yes.
Okay, I'll continue by explaining the technical architecture that powers our system. Our system follows a structured pipeline where data flows through the agent-based architecture before reaching the delivery. We begin with the input and registration layer. Donors, recipients, and the NGOs first sign up, log in, and accept policy terms. Donors provide personal details, medicine information, and images of the medicines that they are donating. The recipient submit location, required medicines, authorized prescriptions from the doctors and urgency level. NGO register using the valid certificates which are verified by the admin. All this raw information is immediately stored to the central database. Next comes the pre-processing. Here the system cleans missing or incorrect entries, unifies the medicine names, extracts text from the images using OCR, and removes duplicate. This stage ensures that the only structured and reliable data moves forward, and the refined data is then updated back into the database. At the core, we use three intelligent agents to automate the decisions and maintain safety. So now the first agent begins the work, the expiry deduction agent. This agent checks whether the medicine is safe to donate, It reads the expiry date from the images and text using OCR, verifies the packaging status, and ensures that the medicine is unopened or and is valid. It uses image analysis and barcode scanning and also rule-based validation. Only approved medicines are marked as eligible in the database. Unsafe entries are rejected. The second agent is the feature
Sorry
selection
to interrupt,
agent.
ma'am, but you have 1 minute to conclude.
Uh, Thank you, sir. This agent ensures only the critical attributes required for the matching, that is medicine type, strength, expiry date, and other required details are given to the next agent, that's the matching agent. This is the most important agent where the crucial step of matching the donor, receiver, and NGO is done. So based on the priority scoring, distance, and compatibility checks, the three users are matched. The strict rule followed here is that no medicine is collected until the real receiver is confirmed. Once matched, the record is locked and notifications are sent to all the three users through the system modules, that is donor, recipient, and admin modules. Finally, the logistics is currently handled by NGOs. However, in future scope, a logistics and tracking agent will also be implemented to have real-time tracking and delivery updates using GPS and notification tools. After the delivery, the verification process starts where the system confirms with both NGO and receiver, checks the proof, marks the donation as completed, and the final status is saved as a verified donation. So the expiry monitoring agent scans the database every day, identifies near expiry medicines, prices their priority, and alerts the matching agent to act faster. So in summary, our platform is not just a workflow diagram, it's a live intelligent system where the decisions are automated using agents. Tools like OCR, barcode scanning, distance APIs, and rule engines drive the logic. Every step is sorry, backed by a centralized database. Medicines moved only after confirmed demand, and the expiry is actively managed. Thank you. We are open for questions.
Yeah, so I want to understand how you have used AI agents, right? So how AI agents are improving upon the results.
Sure, sir. Actually, we've chosen agent Llama Index framework because it can handle structured as well as unstructured data. So as I mentioned in the architecture, we use three agents, that is the matching agent, feature selection agent, and the expiry detection agent. So the expiry agent ensures that the medicines are valid and not expired, where the feature selection agent will extract the required data needed for the matching process, and your matching agent will do the matching work with based on the priority scoring, distance evaluation, and the compatibility checks. So this way, our system is relied on the intelligence system and makes sure the medicine is delivered
Yeah,
safely.
understood. So my question is actually like you have employed the agents. So instead of employing the agents, if I go through the conventional way of doing the things, so is the so the results will be somewhat similar, or so my question is, since the AI agents will be resource extensive, so is the use of AI agents justified?
So you're asking like a comparison between a human doing the work and an agent doing this work?
Not the human, but you can have an ML model or a normal system working, for identification. You can have an ML model to identify the expiry. You can have the ML model or any other model for the different for the two remaining different tasks. So my question is, so by applying AI agents, are we improving upon the performance? Because comparatively, the resource will be on a high resource requirement will be on a higher scale.
Yes,
Understood,
sir.
sir. So basically,
Of course,
sorry for
our
interrupting you.
AI agents have been actually has improved our model and the working part. So our actual system works is that there is a first level of layer where actually AI goes through and checks the OCR and everything from the households, because the images are not all the people from the people like NGOs, they cannot go for each and every households and checks for medicine expiry when they are donating. So the first layer of works with the based on the people first of all uploading their medicines which are not in use by their households, and the second after it's being approved and being to the next level when it's been like concluded as it is okay for the donating purpose, then the people of NGOs like the delivery part comes on the place. So the NGO people are they'll be going into the directly to the households, and they'll be doing a second layer of check whether the medicines as per the photos, and they'll be checking for the second hand. And after those conclusion only will be getting into the donating part, delivering part.
Sir, I want to back up her point, saying that a machine model is just like one brain that only predicts. So it is passive. It waits for it to be asked or instructions to, we need the instructions to make the ML do the work. But while talking about the agents, it is like a brain that can think, decide, and act. So it works autonomously without much human interference. When the ML model says what is that, what is the QR says or what the image is, agent decides what to do the next part. So it's like agent will take the input, reasons it, uses its tools, which the tools may be backed up with ML models as well, and then it takes the action. So ML models where it just predicts and stops, agent will go to the next step of prioritizing, notifying the NGO, and then updating the database too.
Okay, fine. Good work, good work.
Thank you,
Thank you,
sir.
sir.
Thanks.
Now we are moving towards the next presentation. For the next presentation, I like to call Roshni Rajendra for the paper titled Parkinson's Disease Detection from EEG Signals Using Time Frequency Mapping and Auxiliary Deep Dense Inception Network ADDIN. I request the presenter to kindly proceed with their presentation.
I'm audible?
Yes, ma'am, you're clearly audible.
Can everyone see it?
Yes, ma'am, we can see your screen. Please proceed.
Yeah, good morning all. I thank all the session chair for giving me this opportunity. I also thank my guide, Mr. Shangoji Shah. So my topic over here is Parkinson's disease detection for electrophytogram, that is EEG signals using time frequency mapping and auxiliary deep dense inspection network, that is ADDIN. So let us start with the point. Here it is an index. I will explain all the things, that is extract, then introduction, literature review, research gap, proposed methodology, result and discussion, comparative analysis, what I have done, conclusion, future work, and references. So let us start with the abstract. So Parkinson's disease is a progressive neurodegenerative disorder that signifies affect motor and cognitive functions with earlier detection playing a vital role in showing disease progressive and improving patient quality of life. So EEG offers non-invasive and cost-effective modality of capturing brain activity patterns associated with Parkinson's disease. So in this studies, I have studied that EEG signals are transformed into time frequency representation of using continuous virtual transformations enables to extract the rich spectral temporal feature. Here, an auxiliary deep dense inspection network is then employed to learn multi-scale with respect to the patterns from this mapping, while additional dense connectivity ensures effective features reuse the gratitude flow to purpose framework and evaluate the publicly available which we have in the Parkinson's disease datasets and benchmark against recent state-of-the-art approach. Experimental results demonstrates that model achieve an accuracy of 98.5%, precision that of 94, and sensitivity of 98. Here we have seen suppressing hyperexcite dual branch and EEG def model by Nobel margins. These results indicate that the combinations, this frequency mapping with an auxiliary peak dense inspection architectures offer the robust and stable solution to automate Parkinson disease detection for EEG signals, with strong potential for the real-world clinical applications. Introduction: Parkinson's disease is a long-term progressive condition of a nerve system that primarily affect movement, often presenting with rest tumors, slow motions, muscular stiffness, and difficult to balance. Along this hallmark, motor symptoms may patient also experience a range of motor problems such as impaired cognition, depression, sleep disturbance, autonomic irregularity at the cellular level of Parkinson's disease. It is linked to the gradual degenerations of dopamine, providing neural in the substance of media, which disturbs the recurrent balance of neural circuits responsible for contributing voluntary movements. Although the root cause of this still under investigation, current evidence of points and complex interactions between the genetic predisposition and the environmental exposure. Here, it tells that as a population, the number of people living with the Parkinson disease tells and continues to grow unsupportable urgency for the improvement of diagnostic methods and treatment that go beyond symptomatic relief. Earlier detections of Parkinson's disease is critical for improving patients' outcomes as neurodegenerative process underlying the conditions often being years before onset of motor symptoms. By the time classical signs such as tumors, breakers, sentimental losses, and neurons of sustainable nigra has already concerned. Here it tells the potential disease modifying the treatment. Moreover, earlier diagnosis provides the opportunity for timely lifestyle interventions, patients' educations, and participations in clinical trials targeting neuroprotections, which collectively could show disease progressing and reduce long-term disabilities. Let us move to the literature review. The first paper tells us that it has been transformed based end-to-end model that learn long-range temporal dependency for raw EEG and achieve robust patient-level detection across 120 subjects, illustrating the values of attention mechanism over handicrafts features. Thus, the second paper tells us that it has been proposed a real-time detector to convert EEG into STFT spectrograms and feeds them to Google-led, reporting low lactic sustainable for bedside deployment which maintain competitive accuracy. The third paper tells us that suitable for the third paper tells us that propose a wet direction graph framing out the model systematic functions connective among the channels of automatic discovered central integrals link improving discrimination between the ethical and non-ethical signals. The fourth paper tells us that it has a hyperpipeline capable of CNN-based spiral encoding with GRU-based improver model demonstrating gain under the subject-wise validation and emphasizing robustness to pre-processing choices. The fifth paper tells us that proposed a temporal convolutional architecture for automatic emphasize detecting of EEG highlighted that carefully chosen field and attention over the segment of reduced fall alarms to the long records. Next, the sixth paper tells us that progressive and the feature engineering pipeline that combines back and genetic algorithms for features, constructions, and reduction enable lightweight classifier to reveal deep models on based on EEG benchmark. Thus, the seventh paper tells us that propose a dual benchmark network that jointly capture time frequency and statically characteristics of EEG, showing consist improvement over signal streams baseline for action detection. These are the research gaps, few which I have found out. Let us see in deep one by one what it tells us. The first is lack of standardization multimodal dataset. Here, lack of standardization tells us most studies use small signal center dataset, no universal available dataset combining images, speech, gen, and clinical data, limit reproductivity and generational model. Next, it tells us poor integration of non-motor symptoms, and it tells us that non-motor symptoms like REP sleep disorders, multimodal fusion mostly focus on motor symptoms and structural changes. Here, as interpretability tells us that the deep learning model using in fusion and often black box clinical requirements interpret output of clinical adoptions, real-time multimodal fusion challenges. It tells us that sensor-based approach and permission for the real-time monitoring, integrating them with images, labs data in real time is still unaddressed. Next, it tells us a missing data handling. Multimodal data sets often have missing modality due to the patient's non-compliances or cost. Robust data imputation or adaptability fusion strategies are rarely used. This research tells us most work done account of disease progressive over time using RNN, LS, TMS, and transformers. Limited research on handling incomplete mismodalities, example, unavailable of MRIs. Lack of model optimize the age device or real-time variable integrated.
Sorry to interrupt, ma'am, but you have 1 minute to conclude.
Yes, let us move on our proposed model methodology. So detecting Parkinson's disease EEG recording using auxiliary deep dense inspection network short time for the transformation requires a neural network to a signal processing method. Deep learning based on EEG tells us the classification generally consists of three major stages, that is filtering, mapping, and identification. The whole EEG signal consists noise. Here, before containing the characteristics of EEG signal must be filtered and remove noise. Among the first noise reduction method of EEG processing, zero phase low pass filter were the simplest and the most wide used. So EEG signals are a pre-processed and ultimate artifact and noise and may be downsampled of computing effect. After that, we see mapping of time frequency, that is STFP, is a signal process method that divides the EEG signal into a frequency contains using short overlapping time segments. This transforming aids to captured and time varied spectrum properties of EEG data, which may be critical in diagnosing associations of Parkinson's disease. So STFT offers the time frequency as well as representation of EEG data, display how frequency contains varies over time. After that, we see Once it is done, auxiliary deep dense inspection network tells us that made up of many dense, completely linked layers. Here, how it may be used to diagnose the Parkinson's. So, FT specifies the features of providing into the DNN input layer using the hidden layers, and the network layers network learns to automatically extract the higher level of representation from this characteristics. After we are into ADD in classification model, it tells us how the labeled EEG data, which each segment classified and non-classified during the training of network changes, it waits to reduce classification error while learning the different various EEG patterns links with the Parkinson. And after that, it gets the result whether the person having a Parkinson disease or it is a non-Parkinson disease person. So here the result and the discussions tell us that proposed model demonstrate the accuracy of the model will be 98.5%. Then precision will be 94%. Here, well-known methodologies links to the state of art. This criteria also gives an example of common accept and suggestions of the techniques. The method well-known states the art is implemented and tested on the same data sets with
Ma'am,
the
we
same.
request you to wrap up soon as the time limit has
Yes,
exceeded.
yes. Here we see the comparative of the analysis, the various model and the accuracy which is been based on the result. Here tells us the hypercity, the EEG depth, and the dual branches. Gives us the accuracy of the person, whether it is having the Parkinson disease or the not on the moment. On the various multi-models, like you have the MRIs, CT scans, like this. The future work will be like cross data set evaluation with a large Parkinson cohort. Then incorporation of multimodal signals like speech, MRIs, and then we will see that the real-time development portability embedded hardware and explanatory model of clinical interview. These are my references.
So where did you get the EEG data set from? So
For it, like I have taken data sets from private hospitals like from DY Patil or as well as from the Bharati Vidyapeeth, from the neuro department.
okay, so you have generated your own data set, you have collected your own data set.
All clinical data set from the private hospital as well as trying from the government hospital, but it is difficult from the
Okay.
government hospital, so I moved in.
Right. So you have labeled the data yourself, or you had any help with?
Sorry,
You have labeled the data yourself, or you had help with that?
I have labeled the data set.
Yourself, or you had help regarding that? My question is, have you
Yeah,
labeled the data set yourself?
yeah, sir, we have labeled the data with ourselves.
And how many instances of the data you have?
Like we collected different 31 sets, like labeled like whether it is SPV into the tabular form, how the use cases were, then the classification we have taken into it.
No, my question is the number of instances of the data. How many data did you get? How many people data?
It is like 188 near to that,
Okay, okay,
and
okay,
64 people were under the health, you can see, controlled and observed.
okay. So you have since you have collected the data from any agency, so it is better to have a letter from them that you have
Yes,
collected the
yes,
data.
yes, yes, yes. We have the letter. Like we took a
Okay,
permission first, and then through the department, like neurological department, we have done this.
okay. So you
And
might have to increase the data set because 188 and 64, it
so
sounds
this is the
less.
this is my
Yeah,
review paper of a PhD. So the data was not too much not explored. After that,
okay,
we collected like 754 feature data of the people.
okay. Okay. Yeah, fine. Good work. Good
Yeah.
work. Thank you.
Sir.
Thank you, everyone. Now we are moving toward the closing remark. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the 10th version and all the previous 9th version of the conference. We'll be happy to have you in 11th version in 2027. All the participants will be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of SmartCom 2026. I also thank our session chair, Dr. Tatvadarshi, for chairing the session. Sir, this is the token of love and appreciation from the team of SmartCom 2026 and Global Knowledge Research Foundation and partners. I request you to kindly address our participants.
Yeah, thank you. It was indeed a pleasure to listen to all the different research that is being done right from cybersecurity and IoT to AI agents and financial transactions, blockchain. So majority of the trending technologies were touched upon by different authors. So, really good work, everyone, and congratulations on your presentation and publication of your research work.
Thank you, sir, for such motivating words. Now I request everyone to kindly turn on their cameras for a quick virtual snapshot. I again request everyone to kindly turn on their cameras for a quick virtual snapshot. Thank you, everyone. Have a nice day.
Thank you.
Thank you, sir. Thank you, everyone.